Hello, my name is Grant Von Pingle. This is part 2 of Lab 5, the differential equation for the ER and the ICU. So we'll run through real quick and then we'll run it and show what each part talks about. So this is importing different libraries that we need, and this is for the like defining the whole tank, but except instead of tank, like the original code was used for like water tanks, but this one is representing inflow and outflow for a hospital in the emergency room, the ERU and the ICU, the ICU being like the intensive care unit. So we'll run through it real quick. So different variables. So the TE, this is the recovery time I put for the ERU. So how long it takes people to recover in the ERU. So it only takes like zero point 0.8, which is not that long. And this isn't like it's like a multiplier or something. So it's not like a actual constant like zero point 0.8 milliseconds or anything like that. No, it's because you can see down in these equations, where is it? Well, we'll keep going as we go through. So yeah, so TE and TI, you can see the different constant values, but we'll keep going through so it makes sense. So C1, okay, so these two are recovery time for ERU and ICU. And then C1 is inflow into the ICU, and C2 is outflow of the ERU, and C3 is the outflow of the ICU. And during both outflows, there is the constant that makes, so zero point 0.3 will slow it down more and zero point 0.8 will not slow it down more. So it takes less time to recover in the ERU because it's less, um, the injuries are probably less bad, and the ICU takes way longer. So that's why it's zero point 0.3, which delays the amount of space available by taking more time for each person to be inside of the ICU. So right here is the capacity. So I put the ERU and ICU have 20 capacity. It doesn't matter. You can put it whatever you want it to, and honestly, but I just put that as my values. And so this is Q in, which is the people going into the ERU or to the hospital, and then some will go to the ICU, some will leave, some will stay there and get treated and stuff like that. And so this is Q in. So this is also inflow to the ICU. These are like the inflow constants, and this is like the full inflow, and this is the outflow to the ERU. This is the outflow of the ICU with like the different constants, and also this formula right here, the H naught and H1 to the square root, pretty much. And these are differential equations. So this is the ERU equation. So Q in, so basically inflow to the ERU minus the outflow to the ICU minus the outflow of the ERU divided by ERU. So like these are the people that are leaving. Some are going to the ICU and some are just leaving the hospital, all divided by the capacity. And that's how you get the their value. Same thing for ICU, people going into ICU, people going out the ICU divided by space. This is just how to count the capacity until it goes to 1, until it maxes out. And this part is just setting up the waveform. So we'll run it and look at it real quick. So we run it and we can see the blue is the IC or ERU and the red is the ICU. So when we change the waiting time, it will change the slope here. So the ERU fills up pretty linearly until it hits 1 or until it hits 100% capacity, and the ICU is increasing steadily, but it doesn't hit full capacity because less people are going in because there's only a certain amount coming from the ERU. So yeah, that's it. Thank you so much.